Solving a word problem using a system of linear equations of the form ax plus by equals c. Perhaps you don't want to go to the grocery store and you're craving some fruit. A fruit company delivers its fruit in two types of boxes, large and small. A delivery of 5 large boxes and 3 small boxes has a total weight of 112 kilograms. A delivery of 2 large boxes and 12 small boxes has a total weight of 115 kilograms. How much does each type of box weigh? The first thing you want to do in any word problem is to translate some of this English into mathematical symbols. So why don't we go back and read the problem and realize that we want to translate the weight of a large box. Let's call the weight of a large box is L and is measured in kilograms. So I'm going to write the units right here so I don't forget it. And I don't think L needs to be capitalized. So let's write a lowercase l. Now once you get one of the variables, the second variable usually comes intuitively. So let's say the weight of a small box is, let's say, capital S. And once again, that is measured in kilograms. And if you go back and read the problem, look for some information that's very, very useful. So the delivery of 5 large boxes and 3 small boxes has a total weight of 112 kilograms. So this is actually going to make an equation called a kilograms equation. Why don't we say it's 5L plus 3 times capital S is going to equal a total of 112 kilograms. And if you read the second sentence, you get a very similar pattern, and it's also going to be a kilograms equation. So we get 2 large boxes. So why don't we say 2 quantities of the weight of large boxes plus 12 times the weight of a small box is going to equal a total weight of 115 kilograms. And now we are ready to solve this system of equations. Let's say we want to temporarily eliminate L. So let's call this equation 1 and equation 2 here. And I'm actually going to do 2 times equation 1. If you do 2 times equation 1, you simply get 10L plus 6 times S is equal to 224. And now I'm going to do negative 5 times equation 2. And what that notation means is that I'm going to multiply both sides of equation 2 by negative 5. And we get negative 10L minus 60, capital S, and then 115 times 5, so that's about 115 times 5 is 75, so negative 575. And we're going to go ahead and use the addition method. If you use the addition method, we're going to add the 2 equations vertically. And notice the L's are, well, we get 0 quantity of L's. So that's just 0. And we get negative 54 times S. And what's 224 minus 575? Go ahead and take your little handy dandy mathematical microwave here. Go 224 minus 575. We get negative 351. And since negative 54 is not 0, we're going to divide the entire sides by negative 54 so that we could get the weight of a small box. So 351 divided by 54, we get 6 1/2. Why don't we find L? How can we find L? Many ways to do that. Let's use equation 2. If you look at equation 2, and you could solve for L, L is going to be 115 minus 12s, all divided by 2. And we know that S is 6.5 kilograms. So if you plug that in, why don't we use an expression here? Why don't we just put the equal sign here? 115 minus 12 times 6.5 and divided by 2. 12 times 6 is 72, and then 12 halves is 6. So that's 78. 115 minus 78 divided by 2. And what's 115 minus 78? We get 37. So 37 divided by 2. And that is actually, what is that? That is about 18 and a half? Yeah, 18 and a half. So 18.5. Of course, don't forget your units. 18 and a half what? It's actually 18 and a half kilograms, right? So why don't we answer this in a complete sentence? It's always nice to write a summary here. A large box weighs 18 and a half kilograms, and a small box weighs 6.5 kilograms. So as usual, show your work neatly and circle your final answer. Solving a word problem using a system of linear equations of the form y equals mx plus b. Amy will rent a car for the weekend. She can choose one of two plans. The first plan has an initial fee of $40 and costs an additional 50 cents per mile driven. The second plan has no initial fee, but costs 70 cents per mile driven. For what amount of driving do the plans cost the same? What is the cost when the two plans cost the same? So these are two separate questions. And the first thing you want to do in any word problem is translate some of the words into a mathematical symbol. We certainly want to use a variable here. Why don't we use the cost? Let's use the words the cost of a plan. The cost of a plan is the letter capital C. Let's say the number of miles driven is lowercase x. So we really have two different functions here. We have two cost functions. We could say c of x is equal to, let's go back and read the problem. Let's see what the first plan says. The first plan has an initial fee of $40 and costs an additional 50 cents per mile driven. So that's simply a fixed cost of $40 plus 50 cents per mile driven. So that's half an x, or 0.5x, 0.5 times x. Because remember, x is the number of miles, right? If you driven 3 miles, then you multiply 3 times 0.5 and you get $1.50. So that really makes sense. What's the second plan? Well, the second plan is also a cost function. It's could be represented as c of x is equal to no fixed cost, but it costs you 70 cents per mile driven. So it's going to be 0.70 times x, or 0.7 times x. Now I did make a little tiny mistake here. These two functions are different, so I shouldn't use the same variable. So why don't I use c sub 1 and then c sub 2? It does ask, for what amount of driving do the plans cost the same? In other words, in order to answer this, we simply set c1 of x is equal to c2 of x. And we'll go ahead and solve that equation. What is c1 of x equal to c2 of x? That is 40 plus 0.5x is equal to 0.7x. So 40 is equal to 0.2x, which is 2/10 x. Let me erase that decimal there. There we go. And of course that is 1/5. So you multiply both sides by 5. We're in good shape. So we finally get 200 is now equal to x. Now, what are the units? Is it 200 pesos? Is it 200 seconds? Is it 200 feet? You know, for what amount of driving do the two plans cost the same? The plans cost the same when 200 miles are driven. So it's always nice to write an answer in a complete sentence. That way you don't miss labeling the units. What is the cost when the two plans cost the same? We need to find C1 or C2. In other words, we need to evaluate C1 at 200. So take your C1 function and simply evaluate it at 200. And that's the beauty of function notation. We get what? 40 plus 100, and we get 140. Is it rupees? Is it pesos? Is it Hong Kong dollars? No, it's actually US dollars. The cost when the plans cost the same is $140. Circle your final answer. Make sure you show your work neatly. Solving a word problem using a system of linear equations of the form y equals mx plus b. Two pools are being filled with water. To start, the first pool contains 702 liters of water, and the second pool is empty. Water is being added to the first pool at the rate of 16.25 liters per minute. Water is being added to the second pool at a rate of 45.5 liters per minute. After how many minutes will the two pools have the same amount of water? So if you need to, imagine the situation or draw little sketches of the situation. Here's one pool. It already has some water in it. And here's another pool. It doesn't have water in it. And you're simply filling it up at different rates. The one that's empty is actually being filled up more. So you could put more drops of water here to indicate that there's more water going into that empty pool. The first thing you want to do in any word problem is to actually translate some of the words into mathematical symbols. Perhaps we could use a couple of variables. Why don't we let W sub 1, well, let's slow down a little bit. Why don't we use the English? How about the amount of water? The amount of water in the first pool be W sub 1. Once you get that, we could easily figure out what another translation is going to be. Why don't we say the amount of water in the second pool be W sub 2. We also need one more thing. We need another variable. In fact, it's going to be called the independent variable. And that is the number of minutes. The number of minutes is going to be little m. Let's find the amount of water in the first pool. Let's go back and read the problem again. The first pool contains 702 liters of water. And water is being added to the first pool at a rate of 16.25 liters per minute. We're going to write W sub 1. W sub 1 of m is equal to, starts off with 702 liters of water, and then we're going to add, for every minute, we're going to add 16.25 liters. So there is the function for the amount of water in the first pool. In a similar manner, we can get the amount of water in the second pool. W sub 2 of m is equal to, remember this pool started off with empty amount, and now it's the water is increasing at 45.5 liters per minute. We need to answer this question. After how many minutes will the two pools have the same amount of water? In other words, same amount of water really asks us to look at this equation. W sub 1 of m is equal to W sub 2 of m. Why do we do that? When the two amounts of water are identical, we get this equation. And of course, now we could solve for m. What is 45.5 minus 16.25? It is actually 29.25 m. Is now equal to 702. Divide the entire size by 29.25, 29.25, and we should get m. Let's figure out what that is. Turns out to be a nice even 24. So we could say after 24 minutes, the two pools have the same amount of water. And we could circle that. Let's go to the second question. How much water will be in each pool when they have the same amount? So we just need to find either W1 or W2. I want to pick on W2. Let's pick on the function W sub 2. We need to evaluate W sub 2 at 24. We're going to go ahead and use function notation and look at this expression. That is simply 45.5 times 24. Feel free to use your handy dandy mathematical microwave called a calculator. And we get 1092. Now that's not 1092 gallons. Make sure you get your units right. Let's say each pool will have 1092 liters. And there you go. Solving a percent mixture problem using a system of linear equations. The Royal Fruit Company produces two types of fruit drinks. The first type is 30% pure fruit juice, and the second type is 55% pure fruit juice. The company is attempting to produce a fruit drink that contains 45% pure fruit juice. How many pints of each of the two existing types of drink must be used to make 120 pints of a mixture that is 45% pure fruit juice? First thing you want to do is translate some of these words into a mathematical symbol. We typically call the first symbol a variable. So why don't we say the number of pints of the 30% pure fruit juice is capital F. And now we're going to mimic this. And the second one, the number of pints of the 55% pure fruit juice is capital S. Let's read the problem again. The company is attempting to produce a fruit drink that contains 45% pure fruit juice. How many pints of each of the two existing types of drink must be used to make 120 pints of a mixture that is 45% pure fruit juice? So each of these mixtures have different concentrations, but in the end, after you mix it, you're going to get a mixture that contains a concentration of 45% of pure fruit juice. We do know that mixing these two types of fruit juice will get you 120 pints. That means equation 1 could be F plus S is equal to 120 pints. So this is really an equation about pints. We're also going to need an equation that really talks about the amount of pints of pure fruit juice. And the way we're going to do that is use the percentages here, or the concentrations here. We're going to need equation 2, which is 30% of the first type, or times the number of pints of the first type, will get you the total amount of pure fruit juice from the first type. How do we get pure fruit juice from the second type? Well, we're going to multiply it by the concentration of 55% of the second type. And in the end, what do we want? Well, we want a mixture that has 45% concentration, and we multiply it by how many pints in the end? We need to multiply it by 120 pints. So there's equation 2. I am going to simplify equation 2 to be something else, I'm going to multiply it by 100 to the entire sides. So we're going to get 30 times f plus 55 times s. And then if you multiply by 100 here, we get 45 times 120. How much is that? Let's see. We get 5,400. So we're going to take this new equation 2, and we're going to simply solve for f or s or both, because it actually asks you for both. I typically like the addition method here. So I'm going to multiply equation 1 by -3. So if you multiply both sides of equation 1 by -3, I'm sorry, I meant to say -30. Let's try that again. Let's try -30. -30 times equation 1. Multiply equation 1 by -30 to both sides. We get -30f minus 30 times s is equal to, let's see here, 3600 and negative. Okay, we're going to take equation 2 over here and just simply put it right below it, and then we will add the equations vertically, and that's why we often call this the addition method. If you add the equations vertically, you temporarily eliminate f, and we could solve for the number of pints of the second type of juice. We get 25 times s is now equal to, let's see, how much is that? 1,800? Yeah. And of course, take 1,800 divided by 25, and we get s is 72. What does f have to be? Well, it's 120 minus 72. That's about what, 48? Yeah. Why don't we answer the problem in a complete sentence? You will need to mix 48 pints of the first type of juice and you will need 72 pints of the second type of juice. Speaking of all this juice, it sure is making me a little thirsty. But more importantly, when you write things in a complete sentence, you're not going to miss your labels, and it really, really reinforces your understanding of a word problem. Last year, Greg had $10,000 to invest. He invested some of it in an account that paid 9% simple interest per year, and he invested the rest in an account that paid 10% simple interest per year. After 1 year, he received a total of $920 in interest. How much did he invest in each account? Well, we're going to need to translate some of these words into a mathematical symbol. So let's say the number of dollars Greg invested in the 9% account is, let's say, n. Well, we're going to need another variable. The number of dollars Greg invested in the 10% account is t. After 1 year, he received a total of $920 in interest. Well, that was the percent. That's a percentage of how much he had actually invested. We do know the total amount that he's going to invest. So we know that n plus t will give you the total amount, and that total amount is 10,000. Let's call that equation 1. And looking at this, we need another one here. We need a equation that will calculate interest, right? So if we're looking at interest here, if you're going to earn 9% of a dollar, so imagine if you had $1 or $2 or n a number of dollars invested in the 9% account, well, you just take 9% of the number of dollars you invested, you're going to get that interest. What other interest do we have to add? We're going to have to add the interest from the other account, which is just 10% of T. Remember, T is the number of dollars invested in that account. So for every dollar, you're going to gain a dime of interest. Now, what's the total amount of interest earned? Total amount of interest earned is $920, which isn't bad. Let's call this, well, let's not call this anything yet. Let's multiply both sides by 100 to get rid of the decimal. It makes things a lot easier. So we get 9n plus 10t, and we will get 92 with 3 zeros. I am going to take equation 1 now and multiply both sides by -9. So you take equation 1, multiply both sides by -9, you get -9 times n minus 9 times t is equal to -90,000. And then I'm going to call this equation 2. I'm going to place it right here. I'm going to place it right below -9 times equation 1. So that way, we could add things vertically and see what happens. So if you add these things vertically, we then call this the addition method, and we get a t, which is great. We get a t is equal to $2,000. Aha. Well, let's answer the question in a complete sentence. Greg invested $2,000 in the 10% interest account and invested $8,000 in the, what was the other account? In the 9% interest account. And there you go. Typically, if you're given a problem in sentences, you want to answer it back in sentences. Solving a 3x3 system of linear equations. Solve the system. X plus 2y minus z is equal to 9. Negative 2x plus y plus z is equal to -1. 2x minus y plus 2z is equal to -5. If you're ever interested in graphing this, try to draw axes like this, and then really try to label it to scale. So you have an x and a y and a z. And so these are actually equations in 3 space. And if you carefully pick the right ordered triples for equation 1 and equation 2 and equation 3, you will probably surprise yourself. You'll later learn geometrically what this means if you pursue a calculus class. For now, we're just going to do the computation that really involves either multiplying by an equation or adding equations together. Our goal here is to add equations together. We typically don't subtract in math because subtraction is defined to be adding the opposite anyway. Let's look at some of these equations here. And I'm actually going to switch positions for equations 3 and 1. So the first thing I'm going to do is switch 3 and 1. And I'm going to switch 3 and 1 so that I get a 2x minus y plus 2z is equal to -5. Actually, I take that back. let's not switch equation 1. I'm going to stick to a strategy that is more closely related to something you're going to learn later on, and that is something called elementary row operations. I'm going to take advantage of this invisible 1 here. There's an invisible leading 1 there, and I'm going to take advantage of it. Let's actually do 2 times equation 1. Let's do 2 times equation 1. And then add it to equation 2. And I apologize for my labeling. That should just be a 2 right here. This should just be a 2. So I'm going to do 2 times equation 1 and add it to equation 2. And then we're going to get a new system like this. We're going to write x plus 2y minus z is equal to 9. So I still have equation 1, but equation 2 is now changing. Equation 2 is going to change to something like this. 2 times equation 1 added to equation 2. So I get 5y. And then we have negative 2 plus a z. Negative 2z plus a z. So we have minus a z. And then we have 18 minus 1. So we get 17. I'm going to go ahead and do that. I'm also going to do something else. Oh, let me point to what I just did. I went ahead and did that. So I really changed equation 2. So I really have a new equation 2. I'm also going to do something like this. I'm going to take negative 2 times equation 1 and then add it to 3. So I'm going to change equation 3 as well. And equation 3 is going to look something like this now. Negative 2 times equation 1, we got rid of the x. We got 0 times x. So we have negative 4 minus 1. We get negative 5y. And then we got 2z plus 2z. So we got plus 4z. And then we have negative 18 plus a negative 5, so negative 23. So notice our equations 2 and 3 have really changed. I left equation 1 alone, so our system looks a little bit different. So this is our new equation 1, our new equation 2, and our new equation 3. With that in mind, it makes sense to solve for z. All I'm going to do now is go 2 plus 3. I'm simply going to take 2 plus 3 and add them vertically and get a new equation. 2 plus 3, equation 2 plus equation 3. We're going to add them vertically and we get a new equation. We get 0 times y. We get a plus 3z, and that is equal to negative 6. And so now we could divide the entire sides by 3, and we get z is equal to negative 2. Not a total surprise. There's many ways to go back and get y. Let's try to get y from equation 2. So from this new equation 2, I'm going to solve for y. So we got y is equal to z plus 17 divided by 5. But we know what z is. Z is negative 2. So we got y is equal to 3. Now we need to go back and find x. And of course, there's many ways to do that. I'm actually going to go back to the original equation 1. And we get x is now equal to, I think we have 9 plus z minus 2 times y. So that is now equal to 9 minus 2 minus 6. So that's just 1. X is really just the expression 1. Okay, therefore, I guess I could just write it like that. Therefore, x equals 1. So what is our solution set? Our solution set consists of a unique solution. In fact, it is a unique ordered triple. This is singular, by the way. We only have one solution, and that one solution is a set that consists one ordered triple, or it's a set consisting a unique ordered triple. 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 And so the order matters. Make sure you have the set brace and make sure you have the parentheses to indicate an ordered triple. Remember, this is an ordered pair, and now you have an ordered triple, which means you are in 3 dimensions. Let's circle our final answer. Amy, Carlos, and Goran served a total of 81 orders Monday at the school cafeteria. Amy served 9 more orders than Carlos. Goran served 3 times as many orders as Amy. How many orders did they each serve? The key here is to translate one of these words, or I should say a group of these words, into a very, very key variable. And I'm going to pick on Carlos here. It seems like everything is dependent on what Carlos does. So remember that Amy served 9 more orders than Carlos. So let's say the number of orders that Carlos completed. The number of orders that Carlos completed is capital C. We could actually say, in a very similar fashion, right? And we have Goran. So it really depends on what C, or the number of orders that Carlos has completed. And let's find Amy. Amy says it's going to be what? She did 9 more orders than Carlos. So that's really C plus 9. And then we also have Goran. Goran served 3 times as many orders as Amy. So Goran is equal to 3 times A, which is really 3 times what? C, the quantity C plus 9. How many orders did they each serve? Well, we certainly know the total. So if you pick on a total here, let's just add these 3 amounts together. We get C plus 9 plus 3 times the quantity C plus 9. We know that has to equal 81. And if you react to this, you get that 5C plus what? 27 plus 9 is 36, is equal to 81. 5C is now equal to what? 45, yeah. And then C is equal to 9. So once you get C, I'm sure you can finish the problem. You might as well finish writing it in a complete sentence, and so on and so forth. You can easily see that Amy completed 18 orders, and then 18 times 3, well, Goran did how many is that? Is that 54? Yeah, that's 54. 18 times 3 will get you 54 orders. How many orders did they each serve? Make sure you can answer in a complete sentence. Carlos. Oops, I gotta spell Carlos. Carlos served 9 orders. Amy served 18 orders. And Goran served 54 orders. And of course, we all hope they earned a very, very good tip. Oh wait, it's a school cafeteria. Well, I hope they earned a lot of good kudos from their classmates.